Electronic configuration. According to Bohr's model of the atom, each atom contains a different number of electron shells surrounding the central nucleus. Each electron shell can only hold up to a certain number of electrons. The maximum number of electrons in each electron shell is given with the formula 2n to the power of 2, where n represents the number of shells. Electrons go into the shells one by one, starting from the innermost shell. When a certain shell is full, refer to table again. If n is 1, means the first shell can hold a maximum of 2 electrons. If n is 2, means the second shell can hold a maximum of 8 electrons. If n is 3, means the third shell can hold a maximum of 18 electrons. Any remaining electrons would go into the next outer shell and so on, until all are placed. For example, the arrangement of electrons in an argon atom can be shown by Figure 1. Rules for electronic arrangement. We use the following rules. We will take an atom as lithium, with an atomic number of 3. It must have 3 electrons to balance the positive charge of the 3 protons in the nucleus. It's worth remembering that the atomic number tells you the total number of electrons in a neutral atom. So, we put the first electron into the first shell, and the second. However, this shell can only contain a maximum of 2 electrons. That's one of the rules that you need to remember. The third electron, therefore, must go into the next shell, which we draw as a larger circle around the outside of the first, and that completes the electronic configuration of a lithium atom. The same process of filling up shells applies to larger atoms. You always start with the lowest available shell, and whenever a shell is full, the next electron to be added goes into the next shell. You need to know is how many electrons can occupy each shell. And the electronic arrangement of a lithium atom is 2, 1, shown by Figure 2. We will take as another example of the magnesium's atom. Protons and electrons are attracted to each other with electrostatic force. Electrons are arranged in energy levels, or shells around the nucleus of an atom. The actual orbit shapes are a bit too complicated to cover in such a short lesson, but on average the orbital radius increases as the energy levels increase. In our diagrams, the shell nearest the nucleus is going to represent the lowest energy level or shell, and we draw a circle to depict each shell. We use a dot or a cross to represent each electron, and we will represent the nucleus with the chemical symbol. Each electron in an atom is in a particular shell, and the electrons must occupy the lowest available shell, such as the first shell nearest the nucleus. The first shell can hold 2 electrons. The second shell can hold up to 8 electrons. The last 2 electrons go to the third shell. So, when we are drawing the electronic configuration, we have to fill up each shell, in turn starting with the lowest. So, the electronic arrangement of a magnesium atom is 2, 8, 2, shown by Figure 3. At this level you only need to know the rules for the first 20 elements. There are 2 elements you need to pay attention to. They are potassium and calcium. The maximum numbers of electrons are as follows. The first shell can contain a maximum of 2 electrons. The second shell up to 8 electrons. The third shell also has a maximum of 8 electrons. And the last 2 electrons go into the fourth shell. And this would actually represent a calcium atom. Make it easier to count the electrons, and what's more, there's a shorthand way of writing this down: 2, 8, 8, 2. And what's more, there's a shorthand way of writing this down to 8, 8, 2. 2. The first number represents the inner shell or lowest energy level. The comma shows how the electrons are separated between the shells. The second number tells us how many electrons are in the next shell, followed by the third and fourth shells. Also, electronic arrangement can be shown by numbering. And now that you have covered the basics of drawing electron configurations, you'll be ready to tackle our lesson, Electron Configurations of the First 20 Elements. Following the above rules, we can find the electronic arrangements of the elements with atomic numbers 1 to 20. Based on the Bohr's model, the electronic arrangement of potassium should be 2, 8, 9, and calcium should be 2, 8, 10. However, it is incorrect that potassium and calcium should be arranged in 2, 8, 8, 1, and 2, 8, 8, 2. The reason behind this is not included in your syllabus.